Hello, everyone. My name is Ricardo Tellez. I am the CEO of the Construct, and today is a very special day because today is the day of the MoveIt Day. And as an additional event for the MoveIt Day, we are doing this online webinar where we are going to show how to use MoveIt in order to configure an industrial robot. So you can use this industrial robot for planning and making the robot perform trajectories using the ROS packages. As you would see, the ROS Industrial with MoveIt is very simple because almost everything is done. But some steps of configuration need to be done. That's what we are going to see today. And in order to work with this, we are going to use the Robot Ignite Academy. That is here. You can see the Robot Ignite Academy by visiting this link here, www.robotigniteacademy.com. So you have to visit this webpage and then create an account in case that you don't have it. So now I'm going to give you full access to all the people that is on the chat now, directly on the chat right now on the webinar. So I'm going to provide you full free access so you can use it during this webinar to do the exercises that we are going to do all together. Okay, so now go to Robot Ignite Academy and create your account. I'll give you a couple of minutes. So in the meantime, I'm going to write here on the chat that you can go to the Robot Ignite Academy. So I will wait a couple of minutes. So once you are there and you have created your account and you have logged in, I will share with you a link to which you have to follow in order to get the full access to the webinar, to use this platform during the webinar. There is a question here in the chat that says, do we need to send your username or something? Asked by Benjamin Pinaya. So you don't have to send me anything. I'm going to just to share with you on the chat this link here that I am showing here now on the video. And I'm going to share that on the chat. So once you have your account made and created at the Robot Ignite Academy, you have to follow this link. So by following this link, you will automatically have access to the platform with full. So let me answer the question to Benjamin. You just have to create a free account at the Academy. And now I'm going to share the link you must follow to get full access. So everybody follow this link to get full access to the Academy. This is the link. So there it is. If you follow that link, you will reach Robot Ignite Academy and you will receive a message. You want to accept this license for you. You have to say yes, and then you will be set up. So next thing that we are going to do is to go, you press here to the icon of the Robot Ignite Academy, and then you can see the full list of different courses that we have here. And today, what we are going to to see, what we are going to use is the ROS Industrial course that is located here. Then in this course, the only thing that you have to do is to start the course. And then the course will start. So it looks like Karsif has a problem, cannot log in. So let me ask him here in the chat why. So you should not have an error. In theory, you should be able to load. I had an error here on the terminals, and I'm going to reload just to make sure that everything is working properly. Yes, so Francisco is suggesting that maybe the server is on high demand right now. Yes, that's right, probably. And let's see if everybody can connect in the same way as I have been able to. Okay, so let me know if you still cannot connect. And somebody else is saying here that cannot access the account. As you can see in my case, so I have no problem to access here the course of the ROS Industrial. So Benjamin has a problem. He has connect, but he doesn't know where to go. So then more questions about how to join. Then the thing is that you have to come here and see the list of courses. So you press this icon here, Robotic Night Academy, you press the icon, and then you will see the full list of courses. So press the icon of the Academy, and you will get to the courses list. Okay. So once you are there, then you have to select this ROS Industrial course here. Is this one here? And then you press Start the course. And yeah, so then once you press that, you will reach this point here. And here, as you can see on the screen, we have several things. First thing is the notebook that contains the instructions, the full course that will teach you how to use ROS Industrial. It's just an introduction to ROS Industrial, okay? But is that enough in order to introduce you in the subject? So you have this notebook that contains several lessons that you can select from here, from this button here. Now we are doing the introduction, and then we'll move to the creating the URDF, and then we'll try to reach that before the time is up, building a MoveIt package. I think I will stop there, but we have other lessons there that you can do at any point in time, or maybe after the meetup, because you will still have access to the platform for free in along a couple of hours. Okay, so yeah, so maybe you have some delay. It depends because of the server load. So Michael has a problem that cannot connect and don't see the robot. and other people say it indicates that is laggy. You will see that it's not. As you can see, I'm tapping here on the terminal, and it's going very, very fast. So you must have a little bit of patience until everything is loading, because it's a lot of people connecting from everywhere in the world, and then that's the system has a limited size, but it's just a matter of time until it loads everything. So once it loads everything, you will see that you can move fast in here. Okay, so in the meantime that everybody is loading the material, so this is the notebook. You can hide if you don't need it, or you can put it bigger if you need to read better in order to reach the different parts of the tutorial. And then the next thing here is the simulation of the robot. Every part of the courses, every chapter, every unit has a different robot, or not. Maybe it depends. So then here we have this Universal Robot that we are going to use at the beginning to do the demo. Now here you have, of course, one thing, you can also put it big screen, full screen, and have it ready. Great. Then here we have the development environment that you can also put bigger with this button on the corner. And at present, we don't have any files here, just the source directory of the Catkin workspace, but we are going to develop here all our files or packages. And here we have some terminals. We have up to 4 different terminals from which you can launch commands, as you have seen here previously. Okay, so then what we are going to do, you can configure this in different ways. So maybe if we need the IDE to work better here in the center, you configure like that, etc. What we are going to do, I'm going to configure in this way, so the terminal is here bigger. And let's go to follow the instructions of the notebook. And if you read it, more or less, it explains what is ROS Industrial. And ROS Industrial is a series of packages of ROS that allow you to use the industrial robots with ROS. Okay, or it also specifies how you can adapt your industrial robot to use ROS. And by using ROS, that's very interesting, because then you can use in your industrial robot all the different packages that have been developed for ROS-based robots. So you have a large number of algorithms already available for your industrial robot, or debugging tools for your robots, industrial robots. And that's very interesting, because that's something that most of the industrial robots were lacking. So ROS Industrial is really a good idea. And then let's do a demonstration of what you can do with ROS Industrial. Well, what you can do basically with ROS Industrial, this is an industrial robot, so it's basically an arm. And what you want to do with an arm is to move the end effector, that is the part here. This is the end effector. This is the part that will contain a gripper, or will contain a pointer, will contain some actuator that you want to put into some place in order to perform an action. So basically what we want is to move the arm in such a way that the end effector will reach the proper location. This is complex mathematics, and then this is already solved by using ROS Industrial. So let's see an example, okay, about what I mean. So first, I'm going to execute this in the web shell number 1. For example, I'm going to execute this command that is here. Just copy and then paste here. And then this is a demo of what you can do. Okay, so many things will appear. You must do the same thing as I am doing. and let me know on the chat if you have any problem. Bear into mind that there is a small delay of some seconds, like 5 seconds of delay between what I am talking and the chat. The chat is instantaneous, but what I am talking, it's being processed by YouTube, and then it's delivered to you in a delay of about 5 seconds. So bear this in mind. So if you have launched this, nothing happened, but it's not true. What happened is a lot of ROS programs have started and then started. So you should see this sentence that is very nice. Oh, well, everyone is happy. You can start planning now. Then here I see that Jean Carl has a problem. Then Jean, you should copy directly. Copy the command from the notebook. You are missing some part of the command. So let's see if everyone more or less is at this point. I hope yes. So all the ROS programs have already started, but what also has started is one very useful tool of ROS that it's called RBIS. RBIS is a debugging tool that will allow us to configure the movements of the robot to check if everything is performing correctly, etc. So this RBIS has been started on a different window. Okay. Then, in order to see this window where it has been started, you have to press this button here that says Open Graphical Interface. This is this will open a new tab where you will see, let's press Login here. So where you will see that this window has appeared. This is RBIS, okay? But it looks like it's not showing completely correctly. So if you come here to the instructions again, it says, in case that you have this error, you can just type this command to adjust the window to our tab. Okay, so let's write this into another shell. So I'm copying this command and I'm going to type it into another shell. Copy, paste. And by doing this, we can see that now if we go to the tab that opened, we can see here the RBIS is more or less in the middle of the window. And in case that you want to adjust completely, you can move like this up to the corner and press this button here, or you can just do double click on the title of the window. Double click and then automatically adjusts. Great. So far, so good. People, let me know if you have problems. We'll try to solve it in parallel, okay? Great. I see Ron is saying is okay, everything. Very good. So as you can see, this is a very comfortable way of doing webinars. Francisco Crespo is also, and Filippo Lagan. Very good. Darius. Okay, all good. Tom, Kashif also. Kashif, no, sorry, something. Chris is okay. Then Barahat has some problem. He says, when I hit the open interface, I get an error message. Then for Barahat, what? Okay, just, okay, Barahat, just press in case that you have a message error like this one, you can press just reconnect and then will appear. Or if you have you have a login button there on the screen, just press the login button. Then it will appear like this. Okay, Eric, it's okay. Undefined says, undefined, I don't understand that error, bara what? I don't understand your error, but in case that this happened, you can just close the tab and then press it again. Maybe it happens to you that you receive this message. If you receive this message, just press login, reconnect. Yeah, so it depends a lot on the network. It depends, and then so let's continue, okay? Because most of the people are following, so let's continue. So here we have, this is RBIS, and then it contains a vision of the current state of our robot. You see, it's, if I press here, I can move it better. So you can practice at your will and see how it works here, how to move the robot, etc. But what we are going to do is to show how we can use the MoveIt package in order to move the robot, the end effector. So this is the MoveIt screen on RBIS that allow us to plan. For that, what we are going to do just for this demo is to press here on planning. Press here on planning, and then we are going to change the planning attempts from 10 to 4. Let's put 4. Okay, this is to reduce the CPU load. Now, let's see what happens. Okay, so we are following the notebook. As you see, every instruction screen is explained on the notebook. Great. Here it says when we should change the planning attempt. We already have done it. And now we are going to do the demo. So this is just a demo, okay? The purpose of the course is that you learn how to do this demo by your own, for your own robot. The whole course, okay? So now we are going to see what is the expected result. So let's copy this command and launch it here in another terminal. So I'm going to copy and paste. Here. And then the robot should start moving here. So what is happening now is that the MoveIt part here is planning. As you can see, it's planning a movement and then is sending this movement to the robot here to execute. You will see in a few seconds that when the planning is accepted, that it will execute this movement. Let's see. Let me put it on the middle, configure this bigger. Here it goes. Okay, so it executed the plan. It executed the plan. Now it's planning another trajectory, and we see that it's executing the other trajectory. I'm going to move this tab so we can see at the same time both things. Let me do it smaller. Okay, so here it is. So here the MoveIt package is configuring different trajectories, and when it finds the proper plan, then it sends to the rear robot to execute. Okay, and then it finishes. Yes, it finishes with this ugly red error, but basically it's like this. Then we have on the screen, on the chat, that it says Youssef, that he's having a problem with too huge on the whole screen. And that is correct, Youssef. Just execute the following command in another shell. Let me copy this for Youssef because it's a little bit delayed related to us, to the rest. Okay, Okay, so far so good. You have seen what is the expected result of MoveIt. So MoveIt allowed us to use this robot with ROS, planning trajectories for the end effector. So the robot was able to move around and identify what are the different commands that had to be sent to the different joints of the robot, to this one, in order to get this point at a certain position. Okay, so now what we are going to see now is how can we do this for our own robot? That is the key question. Okay, great, good question. I'm glad you asked. Then how? The first thing is that we are going to create an URDF file. So in order to do this demo, you need to have the URDF file of your robot. So first you have to create that URDF file for your robot. And then you have to create the MoveIt package configuration for your industrial robot. So in this course, we do those, we teach those both things, but then also we teach how to perform motion planning using Python. We are not going to see that today because it's too much. So basically, we are going to move to the next chapter where we teach how to create the URDF of your industrial robot, and then we are going to see how can we create a MoveIt package for our industrial robot. Up to here, any question? Any question up to here? So Lagan says, as asking, can we learn how to create the URDF of a differential robot? And what are the algorithms used for path planning? Okay, so first question, Lagan, is related to the URDF of a differential robot. There is a course here. There is a full course that is called Robot Creation with URDF. By using this course, you can see how to create the URDF for almost any robot. So here is the content of that course, creating the visual model, adapted for gazebo simulation, and different examples using Chakro, and then even a project, so you can practice what you have learned in the course. So I recommend you that. Related to the algorithms that are used for path planning, I'm not sure. I'm not sure, but I think that are probabilistic path planning algorithms. I don't know the names. So you should check on the documentation of path planning that it's integrated into the MoveIt package. You should check there. Okay, let's move. Let's continue. So on the first thing, so for the creation of the URDF, and then I have another question of Hanie that says, if the planning of RVs is not desirable, can we change it? Yes, you can change it. You can discard it. There are many, many different options. Where is my tab here? So here, so you can discard, and also you can. So now we were planning and execute. It's like pressing this button here, but you can plan given an endpoint that you would like to, and then decided either to execute or not. Even you can stop at a certain point in time, the executed trajectory. So another question. Kashif indicates if is the access to the whole course will be available after the webinar. The answer is no. So well, I mean, it's available, but not for free. So you can access to all those courses by subscribing to our system, to our Ignite Academy. It's as less as 10 euros per week. So, I mean, it's very affordable. And then Siddhartha is asking, is there any way to get rid of that last error statement as I face the same error? Yes, it is, but I don't know how. So we should dig deeper into this error and see what happens when we are closing. This is the error that Siddhartha is referring to. So we should dig deeper to see where in the code this is being generated, and then prevent that from happening. But I mean, it's at present this is pointless for the demonstration purposes. TF is included into the industrial course, Lagan is asking, and then the answer is that no, but you have another TF course here where you can learn how TF works, and in quite detail. This is the basics: how to publish and subscribe, and then how to create your own robot state publisher, the joint state publisher, how to create the state transforms. So with this course, you can have a lot of information and a lot of knowledge about how to manage TF. Okay, quite a few questions. So now let's keep on moving. Next thing is how to create a URDF. Okay, for a file robot, and then we are going to use this robot for that URDF chapter. Great, we've reached the end of the introduction, so let's move to the next chapter. For that, you press here and select the unit number 2, creating the URDF. As you will see, the whole environment will change. We have here the new notebook with new instructions, and here it's loading the new simulation. And related to Lagan question about the TF, it's already stated here. There is a TF 101 course in the Robot Ignite Academy. Okay, so here it is loading the simulation, and here it is. Here we have it. Great, so we have everything. Now, in order to visualize the URDF file of the simulated robot, we are going to use the RBs tool, as you have seen here on the previous example. Okay, now this screen contains nothing because it has been killed. Then, so now let's launch it again. So let's copy this and paste here. This will launch the RBs, and you can see it here. Okay, so here it has appeared. I'm doing double click on RBs to get it centered. By doing double click, you can get that the system automatically centers this on the screen. Great. Here, let me just move this here so it's easier for us. Great. Next thing. Then we have to add, click on the RBs, we have to add button and then select the robot model option. This is in order to see the robot model is exactly the content of the URDF file that defines your robot. So let's do it. Let's come here to the RBs. Then there is a button here. Hey, sorry. So here, add. Let's press add. And then you can select here robot model. If you go down, 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 here it is, robot model. Select that one. Okay. There it is. So here it's showing, it's trying to get this model of the robot. As you can see, it's not exactly what we have here. No problem. What is happening? That the fixed frame here is not correct. So it's indicating map by default. Then you have to select base link, for example. There it is. Because the map frame doesn't exist. That's why it was complaining. Okay, let me just remove this because. So here we have, just a second, because Tom has a problem here. He cannot get to this tutorial. So for Tom, just press here on the list of units and then select the number 2. This is for Tom. That's it. You will reach this unit. Great. So let's continue with the tutorial. So this is the explanation for the selecting the base link. Now, what it says is that what we are visualizing here is the URDF model of the robot that we have launched here. But of course, what we would like is to visualize the one that we have created. And then that's what we are going to do right now. So let's create a URDF file for an industrial robot and see if we can visualize this here as the same way as we are visualizing this one. So the first thing is we need to create a package, and let's call it my robot description. Okay, so let's do it. Let me change the configuration. Remember that you have here this icon with 4 segments that you can press here and then configure the environment at your own convenience. So I'm going to select this one. You can experiment with that, okay? Great. So now I had to create a package called my robot description. This shell is already taken because I'm executing RBase. So I'm going to select a second shell. And I'm going to create a package. For that, remember, always, you have to create your packages inside the Catkin workspace /source. Okay, so if you see here, we have a Catkin workspace directory, and is there, we have to go to the Catkin workspace. Then here we have the devel, build, and source. We have to go to the source, and there is where we can create our packages. At present, we have nothing, of course, because we have just started. So let's create a package. In order to create a package, remember, Catkin create package. And then the name of the package. As is specified here, my robot description. My robot description. Great. Now it should appear here, the package on the IDE. Automatically should appear if everything is okay. Yeah, here it is. Now I can open it, and then it has created just a CMake list and the package XML. Then here it says, inside this package, create a new folder called URDF. Okay, let's create it. You can do it through the shell if you want, or you can do it through the IDE. I'm going to use now the IDE. So press right-click here on the selected directory, right-click, and then new folder. And I'm going to call it URDF. Hope you are doing the same as me. In case you get stuck, please say something on the chat. Okay, yeah, I pressed twice, so that's why it says already existing. Here it is, the URDF directory. Great. Inside the URDF folder, create a file named my robot URDF. So I'm going to create a new file. I'm going to call my robot.urdf. Okay. and I have it open here, empty. Then write this into the file following the basic structure. Okay, this is for the content, the URDF content of the file of our robot. So let's copy this and paste it here. Great. Then we have to add the world and the camera frame. So let's add it here. Okay, great. We got it. Then we have to add the table. So we are going to add this table also to our model because we are building the same model as here. So let's add the table for the visual and the collision tags. So let me just add it, and then I will explain you a little bit. So here I have added. So what do we have here? Up to here, we have added a robot to the URDF. Okay, the URDF is the file that describes how this simulation of the robot must be constructed. Okay, so first, what we are doing is adding a robot, and this robot is obtained is this line, sorry, is describing this file as the file that describes the robot. Then in this robot description, what we get is first a link that we call the wall. The wall is like the center of the simulation, is the place where our robot will be attached. And then we include another link for the camera, so we can see the scene. Next thing is we add the table, and this is a link for adding the table that we can see here. And the table has two parts. The first part is the visual part. The visual part is the thing that we can see here. So is this texture with these shapes? That's the visual, and we say the geometry. And then the collision is the shape that will be used to compute when the table collides with something. So what happens is that you can provide different things for visual and for collision. For collision, your interest is that the geometry is very simple, because by having a very simple collision shape, your computations will be easier and simpler. But for the visual, is your interest that the table looks very good. So usually you will see, you will put here a mesh, a rich mesh that contains a lot of detail. This is just for visualization. Okay, so let's continue. Then we add two joints to connect both the table and the camera links to the wall link. Okay, so this is the code that does it. Let's add it. Just copy and paste. And then we are almost done. So by doing this, what we have done is just a robot URDF that contains a table, and this table is just a box. Okay, it's just a simple box. It's not the same table as this one. It's just a box, a cube, kind of a cube. Okay, great. Sorry, I have to indicate one thing, is that this robot tag must be removed from here, from the beginning, because this is the closing tag of the robot URDF file. So we have to remove it and put it to the end here. Okay, so after the joint, so it's closing the whole file. Now, you can check that your code is correct by looking at this one. Actually, you could have copy this and paste it. That would be, but it's interesting that we go step by step. So how does it work? This, you have seen the links, And then the joints are the ones that indicate the connections between the different links. So in this joint, we are indicating that the wall is connected to the table. Remember, the table link is the one that we have defined here, and it's the one that contains the shape of the table. And the wall is the one that we have created here, is the basic link of the system from what everything will inherit. So we are indicating, by saying this joint here, we are indicating, okay, connect to the wall link, connect the table link. And with these references. So it means that the table has to be 0.5 meters up from the wall coordinates, and with 0 rotation. So it will be in the same orientation as the wall frame. And in this case, it's for the camera, the same for the camera. So we are indicating that we are going to connect the camera frame also to the wall frame. And the camera is going to be 1 meter on top of the wall reference frame, and with some orientation. So it's half pi on the y-axis. Okay, so far so good. Remember to save the file. When you see the file, this is containing this green stuff here, then it means that it contains unsaved changes. So you better save the file. Saved. Okay, there is no green. So I mean that I have my file updated here. This is the latest, it contains the latest changes. Okay, great. Okay, so now this is just a URDF or a table, a basic table that actually is a square table. It's just a cube. But how can we include the robot? We need the robot. And for that, we are going to use the macro language. Remember, in this course, we are not going into detail into those terms, into the macro or URDF, all the details about this configuration. For that, I recommend you to watch here the URDF. Where is it? The URDF. I cannot find it. Here, ROS creation with URDF. Here it is, course. Here it contains a lot of details about how those instructions work and how better explanation. Okay, this is just for going into the example of ROS Industrial. Okay, so building the chakra. Then the chakra, it's a language on, let's say, on top of URDF. It's a macro language that allows you to concatenate different URDF files. And so that by doing this, you can, for example, create a robot that has 8 arms by creating a single URDF arm and then multiplying this into a chakra macro, indicating that this URDF has to be copied 8 times. So basically, that's the purpose of chakra, and that's why it's very purposeful. And then what we are going to do is to continue with this in order to include a robot on top of this table. So first, let's rename the robot URDF file into my robot chakra. Okay, let's change it. So here we have the file. Then in order to rename, you can use the web shell, or you can use here the IDE. So I'm going to use the IDE because it's simpler. Press right click and then rename. And let's change this for chakra. Okay, my robot chakra. Great. Now, what else? Then we have to include into the file the Chakro macro that loads the Motoman robot. The Motoman robot is the model of this robotic industrial robot here. This is called the Motoman, and we have already installed in the system the Chakra that defines the whole robot. So for that, we can include this here into the URDF. So let's put it here at the beginning. Now, then we have, even if we have, sorry, this has to be, let me see. Okay, yes, okay. So this works like an include. This instruction here is not actually inserting. It's not inserting the robot into the description of the robot, but it's just indicating, hey, we have include this file that contains definitions of robots. That's the only thing. It's like an include in C++ or an import in Python. So that's it. But we have done nothing yet. So then in order to actually include the robot that is defined in this Chakra, we have to include this other line here. Okay. So I see that we have some problems here on the chat. Then with Ali that has suddenly have no access to the code from which you are using the code. Okay. So I don't understand very well your question. If you can explain in another way. So in the meantime, so I have, as I explained, we have done the include, and then we have indicated that we want the Motoman robot included into the simulation rate. And then, so Ali is asking for access to the course, and then it's not possible now that we go so far back because many people is already following. So I'm sorry for that. Try to follow as much as possible. And then in case that you want, you can start from the beginning when we publish the course online. This webinar is going to be published later. Okay, so now we have included the Motoman, but in the same way as we included those links for the table or for the camera, we have to attach this robot using a joint to some place in the world. And let me write it here, add it here at the end. And then we are going to attach to the table. So it means that the Motoman will be on top of the table. So let's copy and paste. Okay, and then we are done with the model. This is a model that contains a table that is actually a cube, and then the Motoman that is being explained is being created in this Chakra file. So we are not going to explain how to create this Chakra for that robot because it's quite complex. So as I said, if you want to, you can use this course in order to build your own robot, or even go to the wiki tutorials that explain how to create the URDF for your robot. Great, so remember to save. And now we are going to create a launch file that is the one that is going to launch this simulation. So for that, I'm going to create another launch folder here. And inside the launch, I'm going to create the launch file. my robot. Okay, and then here is what it says in order to launch our file. So let's copy this and paste it, and then let's explain a little bit how it works. I'm going to put this a little bit bigger. Great. So what it does, this file, let's save first, so we don't forget. And then what it's doing is, this launch file, first it accepts an argument that is a GUI, if it's going to show the GUI, and then it says true by default, yes. So then we have a parent name. We are loading a parent name that is a robot description. As you remember, robot description is the parameter that we are loading here for the robot model. So here we have the robot model, and the robot description is this parameter. So we specify here the robot description parameter is the one that is describing the robot. So that is what we are indicating here. This robot description, please fill it with the Chakro file that you can find in my robot description package /URDF, my robot Chakro. Okay, this is exactly this file that we have created here. Then afterwards, launch the RBIS. So, and this GUI parameter is going to take it into account here. So if it is true, then RBIS will be launching. Basically, that's it. We got it. So we have everything, and let's check that. Let's check that we have everything correct. This is the example of the, no, sorry, it's below. Yeah. Here it is. Okay, so we were here. Okay. Then, so far, so good. Then let's do one thing. Let's launch this file and see what happened. But before, we are going to close this RBIS that we launched it here, because otherwise it will conflict with the one that we are going to launch here. So you can close it by Control-C, and as you can see, it will, well, if I reconnect, nothing is here, so it died. Great. Now, let's launch it, then let's do it. Let's do a robot launch, a ROS launch. My robot description. My robot launch. Okay. Great. So now RBIS has been launched, and our Chakro model has been loaded into the robot description. So if we go to this graphical interface that I already opened and is here, we can see it here. Double click to center, and then I'm going to add the robot model. So if I go down, robot model, here it is. And of course, we have to change here the link to the base link. And here we are. So as you can see here, we can see this is the URDF of our robot, the one that we have created. You see, this is the table. That is a very simple table. It's just a cube. And then the Motoman on top. Okay, so this is the one that we have created here in the Chakro. And it contains a table that is very small. It's 1 × 1 and 5 centimeters of 8. So that is why you can see here it's very, very small. Okay, so this is a way of creating a URDF of your robot for your industrial robot. Then, of course, the most important part here is about creating this chakra file. So for that, again, let me tell you that maybe it's interesting for you to create this URDF. Also, for most common and popular industrial robots, the URDF has been already created, like in this case. So we did not create this model. We took it from internet that is already available. Okay. Yeah. So far, so this is some comments related. Yeah. So Filippo is asking a question. Yes. So there are some errors here. You see, like the robot model, it appears in red, and this is what Filippo is indicating here. It's for the camera and for the table. And this is right. This is because nobody is publishing, is creating a transformation for the camera, from the camera to the base link, or from the camera to the wall. Nobody is publishing that transformation. So in order to get those errors out, the same happens with the table. Okay, so in order to get those errors out, we should include in this launch file a publisher. In this launch file, we should include, for example, a static transform that publishes the transform between the camera and the wall link, and the table and the wall link, for example, or the base link, or any of the links that we have here. Okay, and then your next question should be, okay, but why is this happening for the camera and the table, but it's not happening for the rest of the parts of the robot? And that would be a very good question also. It's because, remember that we have launched this simulation with the same model. So this simulation is launched at present in our system at the same time as we have launched our robot description. Okay, so our robot description is here, and this one is also there. And the simulation is the one publishing the TF transforms for this robot. And because the robot is the same in our case, that's why it's with the same names, with the same frames. That's why we are seeing these transforms that are correct. In this case, it's using the transforms of this robot here. Okay, so if you want to know how to create a static transform, you can check our course on TF here. We indicate TF ROS 101. We indicate how to create a static transform and other types of transforms. So here, that would be here, Unit 5, static transforms. Great. So, okay, let's go for the final part. Then let's move to the next section, and we are going to finish. Next section is to build the MoveIt package. But wait, before we do that, let's execute this command, because we have to. Let's close first our program, and then let's launch this sentence here. This command was launch URDF tutorial, because by doing this, we are preparing our system for the next unit. Oh. Okay, so yes. Great. Great. So let's go to the next section. That is the one that builds a MoveIt package. And then, but for doing a movie package for industrial robot is is easier than it looks, because the guys from MoveIt have created an amazing setup assistant, and just by launching that, it's almost like going next, next, next. So let's do that. Let's go on the next Windows style. So the first thing, in order to do that, to start the setup assistant, is to launch this command, ROS launch MoveIt setup assistant. So use any of the shell to execute the launch assistant. And then go to the graphic tools tab. If you haven't opened, you press this button here and it will appear here. Great. Then next thing, it says you can create a new one, or you can use an existing one in order to modify it, etc. In our case, we are going to create a new MoveIt configuration for this robot that we have in the simulation. So it's a MoveIt configuration package. So let me just summarize up to here. What you need in order to move an industrial robot with ROS is, first, you have to create the URDF file of the robot, and then you had to create its MoveIt configuration package. That's what you need. And so we have covered how to create the URDF on the previous section, and now we are going to see how to create this MoveIt configuration package. And it's quite simple, as you can see. So let's go. Then let's create a new MoveIt configuration package. And then in this case, we have to, where it's the existing, where it does exist the URDF file. So let's go. I don't remember now. Where is it? So, okay, it says located in the previous chapter. And in the previous chapter is, so I don't remember exactly where it is, because let me check. No. Okay, so in the previous chapter, let me see if it's here. Okay, see a description. Here, URDF and URDF. Okay. So let's see, because I have some problem here. Okay. So yeah, it is not indicating where it is. So, well, let's try that one. Okay, yeah, so it was that one. So please, when you select the files, go to OPT, ROS, Indigo, Share, and then the name of the model, SIA10f, description. Then the URDF, and then the SIA10f URDF. And here we have something. So I think that there is a problem with the size of the window. Yeah. Because we should have another. Yes. Okay. Yeah. So Lagan is indicating that if I can type it here, yes. So I'm going to type it. ROS Indigo share CRN solution slash URDF CRN-F. Okay, so yeah, so I think I'm missing something here. Let me put it bigger. Okay, yeah, so now it's loaded. Sorry, I pressed the load files button without almost noticing, and then it has loaded correctly. Great, so we have it. We have it working. So in this case, we have loaded it. Oh, okay, sorry. I think in this case, yeah, so it's requesting us to use the one that we created on the previous file. You see, as the model loaded, is the new one. So yeah, let's go back then. So for that, sorry for the error. Let's go back, Control C. So I have killed the application, the MoveIt configuration, and then I'm going to launch it again. Great. So create a new MoveIt package, and then let's browse to our user place, Catkin workspace, source, my robot description, URDF, my robot chakra, and then press load files. Okay, now it is. So this is the one that we have to do. Sorry for the confusion, guys. So here we have the model that we have created on the previous exercise. Of course, it makes sense that we built on what we have already done. And this is similar to what we get here on the screen. Then, next thing, let's go to the Self Collisions tab and click on Regenerate Default Collision Matrix button. And we'll get a list of all the collision matrix. Then Self Collisions, and then Regenerate Default Collision Matrix. Okay. We got it. Then this is the list of all the links and how they collide or not collide between them. Great. Then now we have to move to the virtual joints tab, and then we are going to define a virtual joint for the base of the robot. So let's go. Virtual joints. So here it is, and then add virtual join. And the name that we are going to do is fixed base, and the parent is the wall. So fixed base, we have here fixed base, and the parent is the wall. So here in parent, we are going to say wall. Okay. Yeah, so Lagan is indicating on the chat that he's not getting it. So for Lagan, sorry, but we had to restart the MoveIt config manager. And then get the chakra description that we have created. Great. Hope that this is helping to continue. So The thing is that the tutorial that we are following here, as you can see, is very self-descriptive, and then it's showing step-by-step screens of what you should get. So you could even follow this by yourself. Okay, so if we have it, then we just press save. Great. And then let's go for the next step. Now open the planning groups tab, and then we add a group button. And we are going to create a group, a new group that we'll call manipulator. Let's go for that. Manipulator. Here in this group name field, we are going to put manipulator. And let's see if we had to change any other, which uses KDL kinematics plugin. So let's select here in the kinematic solver. This is one of the questions that was asked at the beginning of the session. So here you have one of the lists of the different kinematic solvers, and you can check those here. And the one is that we are going to use is the KDL kinematics plugin here. Okay, so KDL kinematics plugin. Great. And what else? The next step is add kit chain button. Base link as base link and link tool as the tip link. Link tool 0 is okay. So here is a button that is called add kinematic chain, and here base link, we are going to select the base link. For the kinematic chain, I have a delay on my screen, so that's why I'm not continuing. So let's continue now. Here, base link. So I select that, and then I say base link. It's base link as the base link. Okay, so I select this base link, and I press here choose selected. So it's set up. And then as the tip link, we are going to use the link tool 0. So let's go down into the kinematic chain until we get that link. Link B, T, link tool 0. Okay, so this is the tip link. Great. So it means that it has to plan using all the kinematic chain. And then finally, we have to save. Yeah, that's done. Okay, save. There it is. Great, next step. Then let's, so yeah, we have this screen, so this is correct. Now, we are going to create a couple of predefined poses so we can use them for check that everything is okay, or we can use it for setting the robot in a specific position that we know always is a safe position or a starting position or something like that. For example, in this case, it suggests like everything with zeros, and we call it all zeros. So let's do it. For that, we have to go to the robot poses. I'm getting a delay here. So, and add a pose. And it said that we have to call it all zeros. All zeros. And with everything with 0. That's already by default. So let's save it. And then I think we have to create another, yes, with another specific position, and we'll call it home. So let's add another position, add another pose that we call it home. And here everybody can play with the joints and indicate, select the position that it wants. So I'm going to move a little bit the robot, the different joints. You can experiment here, and you can see on the left-hand side how the movements of the joints affect to the robot. So I'm going to put it like this, and then like that, and then like that, for example, and then like that. Okay, so that will be my home position, for example. Whatever the value is, all of them are okay. It's just an example. Great. Then, yeah, well, it says indicate the email of the author in the tab, and then so we go to the configuration files and click browse button to indicate where we are going to create our MoveIt config package. So let's go to the configuration files and create this configuration package. So based on all the information that we have introduced here on the MoveIt, then we are able to create a configuration package for ROS for handling this robot. Remember that we begun this MoveIt config wizard by using the URDF that we have created. So that's why the URDF is so important. Okay, so I'm going to create this in our Catkin workspace. So here it is, and this source will be we are going to create. So I'm going to choose, and wait a second because we have a question here from Andrew, and he's asking if this video will be available later to review. And yes, the answer is yes. Yes, it will be available after a couple of hours that we finish. Okay, great. So we were doing, yes, creating the package. So once we have selected the directory where we are going to save this config, then we just save the package by pressing the generate package button here that is included here. Okay, so it says that I need to put the email address and everything. So I'm going back to the author information tab. Name of the maintainer of this configuration, I'm going to put my name, and I'm going to include also my email. So in order to prevent the movie to complain about this. And we are experiencing some connection problems. This is due to my internet connection, and but hopefully the system is quite strong and then recovers from that. So here it is, and now we can go to the configuration files again and generate the package. Now, end effectors have been added. Okay, yes, because this robot doesn't have any end effector. Yeah, okay. Okay, so folder package is incorrect. Wait, sorry. Maybe. Okay, wait. So what is my... Okay, so I have, yeah, I have to create myself the directory. My robot MoveIt config. Okay, so let's go back here, ROS, here, create a new directory that is called my robot MoveIt config. And my robot MoveIt, yes, yes, that's correct. So Tom and Banks is indicating just exactly this. Thanks, you are correct. And let's reconnect my robot MoveIt, my robot MoveIt config. Okay. Okay, now we can generate the package, knowing the factors, okay, and generate it. Okay, great. Yeah, those errors, those mistakes, it happens. It happened to me many times, so don't worry. This is not important. We can solve those. Let's keep on pushing. Then we are almost there. So we have generated the package. Everything is okay. And okay, so now what? So let's do some basic MoveIt planning, motion planning. Great. For that, we can close that because it's already done. Exit, set up the system, and done. Now let's do some movement demos. So for that, we can launch just the MoveIt. We can use the MoveIt config package that has been created by the assistant that is, as you can see, is created here. So it has been populated with all the data related to the use of the robot with MoveIt for this specific robot. So let's do it. Let's launch it and see what we can do. Copy and paste. Okay. Then it says that it's not existing. Yes, it is there. My robot. Okay. Yeah, because there is a mistake here. There is no hyphen. So we need to add here a hyphen and underscore. So let's launch it. Here it is. Everybody's happy and we can start planning. And again, it will have open the configuration window for MoveIt in RBase here. So let's apply again this command for centering the window here, for example. And let's do a double click to set up. Great. And it looks quite similar to what we have here. Okay, yes, if you use everything goes okay, you will see something like this. Right. Okay, let's go to the planning tab, and then what it suggests is before start planning, we can update the current start state by pressing this button. It's just to let the planning know that the current position is the actual current one. The data that has of the current position is the actual position of the robot. So let's go to the planning tab and planning tab here, and then say current. Let's select here current and then update. Okay, great. Now is that we can select random valid option. So here and then update button. So the system will select a new random position that is available for this robot in its motion space, and then it will show us a possible position that the robot can reach. It's a random one, okay? Then if we click on the plan button, then we'll see how the robot is planning to reach that position. This is just planning, okay? It's trying to see if it's possible to reach from its current position to the random position that we have generated. And finally, if we execute that trajectory, and then we'll see how it reaches this. And then Bamsi is indicating that he thinks that we need to change the start state to current. Yes, so yes, I have done it here. Sorry, maybe I miss it. It's here. So where it says, I don't remember what was the original option. So you have to select here, current, and then update, in order to make the system recognize the current position of the robot. Okay, so now what we are going to do is to change there to random valid, again, to generate a possible trajectory of the robot. Possible position of the robot. Then we'll press plan and see how the robot is planning to achieve that. But at this moment, still the robot, this simulated robot, is not moving at all because it's just planning. So it says that I changed the goal state. Okay. Yes. Okay, so yeah, wait, okay. So okay, yes, that's right. So I missed that one. Okay, yes, so Bamsi is indicating that I changed the goal state instead of the start state, and that he is right. So you are right. Thanks. Thank you. So yeah, we have to select the current and then update. Okay, great. And then the goal state, we should random valid and then update. So as I have pressed this update, then the system has generated a random valid goal state that is here as a possible place to go. And then it says, hey, you can move this robot to this position. Okay, so great. Then let's do one thing. Let's find a plan for executing that position. Okay, so let's press here, planning. And the robot is trying to get a plan to reach that trajectory. And finally, it has achieved that. So after several attempts, it has achieved. So it's saying, okay, going from my blue position to the orange position, I can do this trajectory. Okay, then as you can see at this moment, still the robot hasn't moved. The robot is here and we see nothing here because it's just like thinking, I'm going to do that, or I don't know. Okay, so now if we press the execute, we'll get the robot to actually execute the trajectory. So you have pressed execute. Now we should see the robot moving into that position. Yes, the problem with MoveIt is, well, is like all the planners for ARM robots, like the industrial robots, is that it takes some time to find a plan and then execute it. Or maybe it has a problem. Execute, you should have execute that already. You should have execute, and something wrong here. Yes, is executed. It says it indicates execute. Okay, I'm going to plan again. I'm going to repeat the process. I don't know what happened now because it hasn't generated that. So let's update. Let me update a different random position, for example, that one, and then plan towards that one. Okay, this is not possible because he thinks that he is on a different start state. So we have to update the initial state because the current state is like this. Okay, so let's start and then update. To all zeros. Okay, so definitely there is some errors here because it should move the start state to the all zeros position that we have defined before, but it's not doing it, so I don't know why. Sorry, yes, Alberto has indicated that he has executed the trajectory in MoveIt, but you need to continue the unit in order to connect to MoveIt to the simulation. Okay, so I missed this this section. Okay, yes, that's right. Alberto is right. Okay, so what we have found here, up to here, is a way only of creating a plan and being able to execute that plan. Now we need to, as Alberto is indicating, we need to execute this plan into the simulation itself. And for that, we need to do some extra work yet. Let's do it then. Let's go for it. Then the thing we have to do is, and so we have to create a config file inside the config directory of MoveIt. We have to, let me check it here. We have to create a new file called controllers jam. So let's create it here, new file. And this file contains the list of controllers that we are going to use to control the joints of the robot. So you can analyze how this works. I'm not going to explain here how it works because it's getting late already, but you can check in our Ignite Academy. We have a course about the ROS controllers that it's here, and then you can see it's called ROS Control 101, and you can use that for understanding better how this control jam file works. Okay, so here it explains how it works, and we are going to skip that. So again, we need to create inside the config file also another file that contains the join names. So let's call it joinnames.jam. Here it is. And then it has to contain all this. This is already prepared for the Motoman robot. So again, if you need to understand that, go to the controllers course. Now, if we go to the MoveIt Controller Manager Launch, and it has to be here, XML, my robot movie controller manager launch here. Here we had to put the following content inside. Okay, let me check that everything is correct on the files. Yes, okay. So let me save it. And then I'm skipping these explanations because too much detail, but you can check it on your way. So if you want, and then finally, let me see a question that is on the chat. Okay, so the question is, that is asking is a very good question. Do we have an Ubuntu image with ROS, Python, and all the necessary libraries for your examples pre-installed? No, we don't have that. We don't have an image for that. What you can use is, of course, our academy, or for learning for that, or in case that you would like to have all that pre-installed in a web environment, then where you should see, you should go to the RDS. The RDS is the ROS Development Studio that we have created also, and it works on the same philosophy as the Robot Ignite Academy. And here you can launch any of those simulations, or you can upload your own simulations, and everything is already pre-installed here. You only need to have your simulation. Even if you don't have a simulation, you can use the ones that are provided here. For example, for armed robots, we have this one, Shadow Robot, or One Robot, wheel robots, turtle bots, drones, etc. So this is to answer your question. Again, getting back to here, so let me just write it here. So for that question, I suggest you to use the ROS Development Studio. Yes.constructsim.com. Okay, so far so good. Then let's go for the finals to create a new launch file that setups the system for controlling the robot using those controllers that we have indicated. Then let's go for here inside the launch. Let's create another file. Call it my robot planning execution launch. And here we have a problem because we have been calling this my underscore robot, and here it contains my robot without underscore. So we have to add this here, otherwise nothing will work. Here my robot movie config, here again also, and my robot movie config here. Okay, so I think that's correct now. So then let's launch this file and then plan a trajectory. So then when we execute the button, then the trajectory should be executed. Yeah. Sorry, Lagan is asking something, but I don't understand your question, sorry. Yeah, so now let's launch this file in any other shell, for example, and then cross launch my robot MoveIt config, and then my robot planning execution launch. And we have a problem, yes, because we have some place that we still have my robot. And let me see, where is it? This problem. It's on some place we have included here, maybe. Or the controllers. Follow, no, here there is nothing. So it has to be here in some place, but I cannot see it. My robot, MoveIt. Okay. Resource not found. Let me check. I think I have saved everything. No. So, so I have a problem here. So place, I have included my robot MoveIt config. Instead, I have included my robot someplace instead of indicating my underscore robot. Okay, let me check. Where can it be? In the config files. Controller join names. This is correct. So let's remove it. This is also correct. The robot description. This is, let's move it. Here, here it is. Okay. Yeah, I didn't change here on the controller manager launch. Okay, so I think it's here. So I have saved, and then let's launch it again. Okay, so there it goes. So now let's try again. Let's try again here to in the meantime that my display refreshes. Let me see. Okay, something is wrong here. Yeah, let's reconnect here. Okay, yeah, so we have two executions of the RBS. Let me cancel that one. And let me also cancel the other one, because it can have a collision of the different packages. So now we have nothing. And then let's launch again the my robot planning execution launch file. And we must see here the execution of the planner. So let's do again, let's center the window with this command. Okay, so I'm centering again. Then let's go to planning. Let's select the start state is the current. This is great. This is working. And then in select goal state, let's say update to select a new random position. We got it here. So now let's plan it. Now it has found this plan. Okay, great. And now let's execute. If I press execute and go here to the robot, I should see the robot moving to that position. So execute. Here it goes. Here it goes. Okay, so we finally got it. We finally got it. So now I can select another random valid position, then plan, and also plan to check if there is from current position to the new one, and then execute. And we'll see how it executes in the simulation. Great. Okay, so we are going to stop here. And then what we have seen here is how to make industrial robot use ROS packages for planning in an environment with very few clicks. Actually, we didn't have to do so much for making this work. And then the next step will be to use all these config files that we have done, all these planning, all these executions from a Python program, because that's what interests you. Of course, you have to create your own code, your own programs with Python that allow you to move the robot using MoveIt. This is the next unit of the course that we are not going to do today, maybe another day in another webinar if you require. So for today, we are going to stop here. I hope that you got an interesting view of what MoveIt can do for you and for your industrial robots. And in case that you have questions, you can send us the questions to our email that I'm going to put it here. I'm going to write it here. So send questions to info@constructsim.com. And we will be happy to answer that. Also, you can put them, you can put the questions beneath this video that will be available in a couple of hours. Okay, I hope you enjoyed this webinar. Let me tell you that we have other webinars being prepared about how to teach ROS using this tool. As you can see, I have been doing conducting the whole webinar using the tutorials and with the simulations, and the people has been able to follow doing at the same time the exercises. Of course, imagine if you have a class, so you are in front of the class, you can be with your students and you can see what they are doing on their screens. That would be amazing also. That would be even greater. But in a limited situation like this one, then you can see how this tool, the Robot Ignite Academy, it can be for teaching to your students. So thank you very much for attending. Don't forget to subscribe so you will get the notification when this video is published. In order to get the notification, remember that you don't have only to subscribe, but to activate the bell. There is a bell, you have to say, hey, I want to get the notification. So by doing this, you will receive every time that we publish a video. Bear in mind that we are publishing new videos every day, containing always practical material for learning ROS, for solving problems with ROS. And just a final thing is that next week, we are going to start a new program online that is called ROS Mastery Live Show. In this webinar, we are going to answer practical questions of the audience. So you can send us questions that you would like for related to your own projects. I will answer those questions online and show you how to solve those problems. So I hope to see all of you on those webinars starting next Wednesday. And thank you very much for attending.